Alright. Um, so for this video, we're gonna solve equations. Ne? The equations we're going to solve, they have exponents. So that means we're gonna have to use laws of exponents. Right. So there's this young rule for equations when we are solving. We say if the bases are the same, the exponents must be the same. We use that rule when you have an equation, right? So when you do have an equation, we will then say if the bases are the same, the exponents have to be the same. Ne? So for example, you solve this one, you have 3 to the power of x plus 1. Here, base 3, 3 to the power of 2. So the bases are the same here. That means what? Our exponents have to be the same. So therefore, x plus 1 equals to 2, x equals to 2 minus 1, x equals to 1. And then when you go and test it, 3 to the power of 2 to the power of 1 plus 1 is 3 squared, which is 9. Ne? For this one, beautiful stuff. 3t 3 to the power of 0. Bases are the same, exponents must be the same, therefore t equals to 0. Here we have the beautiful one. This one, let's transpose. You have 2 to the power of x equals to 2 to the power of 4 minus x. Right. Bases are the same, therefore x equals to 4 minus x. You have x plus x, you have 4, 2x, 4, therefore x equals to 2. Right, we go test it. We say 4 minus 2 equals to 2, and exactly 2 to the power of 2 minus 2 to the power of 2 equals to 0. We come to this one, very beautiful stuffs. Let me see. Okay, cool. I think 64 is 2 to the power of 6. Yes, so this is 2 to the power of 6 into y plus 1. Then 16 is 2 to the power of 4. 4 into 2y plus 5. Ne? And then you have these two. What do you then do? Bases are the same, the exponents must be the same. Therefore, you have 6y plus 1, 4, 2y plus 5. And then that is 6y plus 6. That is 8y plus 20. 8y minus 6y. 6 minus 20. You have 14 minus 14. You have 2y. So here, therefore, y equals to minus 7. Right. We test it out to say 64 to the power of minus 7 plus 1. Okay. I'm getting numbers that are crazy, so I know I have 64 to the power of minus 6 minus 7 plus 1. And then if I go that side, I know I have 16 to the power of minus 14 plus 5, right, which is, this is 16 to the power of minus 9, right? Yeah. Wait. 5 minus 14, 9. Yeah. And then so then 16, this is the same as it's the same as 2 to the power of 4, then times minus 9, right? If I come here, okay, let me say the answer here is gonna be 36, oh, minus 36, and then here, okay, let me do it properly, man. Let me do it properly and stop doing all these messes now. So we have solved everything. The bases are the same. We therefore multiply the exponents. We have 6y6, we have 8y, we have 20. We do the transposing, so 8y, go that side, 6, 2, we have 26, right? That is 14 minus 14, right? So minus 14, we have therefore x, y be minus 7. So now we go, perhaps I shouldn't have deleted 2 to the power of 6 into, well, let me just say y plus, let me write it as minus 7 plus 1, right? And then here I have 2 to the power of 4 to the power of 2 minus 7 plus 5. So I have 2 to the power of 6 into minus 6, which is 2 to the power of minus 36, yeah? And then I have 2 to the power of 4 into that is 9 minus 9, right? 2 times minus 7 plus 5, that is minus 9, which, like we said, that is 2 to the power of minus 36. So the same thing, everything is equal. Beautiful stuff here, beautiful stuff. So this, we have this thing, this is really beautiful, or like what I'm seeing here, né? Because already this is 7, I know this is 7 squared. You see, so this is 3x, né? I know this is yeah. So and then we already have the bracket, so the factorization has already happened for us. So then we then say 7x equals to 49, or 3x equals to 27, all right? And then 7x equals to 7 squared, 3x equals to 3 to the power of 3, therefore x equals to 2, or x equals to 3. You understand, brothers? Cool stuff. Let's continue to cook. We have the similar situation here. You're just gonna say, of course, here you could say you have 2 to the power of x plus 1 equals to 2 to the power of 4, which is 16. Let's confirm it. 16. Or you're gonna have the side 3x plus 1 being equals to 3 squared, right? Then you could say therefore x plus 1 equals to 4, x plus 1 equals to 2, x equals to 2 minus 1, x equals to 1, x equals to 4 minus 1, x equals to 3. Sure. Then it's done. Next one is a beautiful example. This one, you have 2 to the power of a, convert this into a fraction, you have 1 over, no, you have 1 to 5 all over 1,000, right? Which now, what can we say? Yeah, now you have 2 to the power of a, you have oh no, so okay, I'm trying to think here. Wait, did I, because I'm seeing this is 5 to the power of 3 and this is 10 to the power of 3, right? And the base is not the same. So let me just check if I actually noted the question right. I hope I didn't make a mistake. It looks very interesting, so I want to actually do it. But yeah, I need to check if I didn't do any mistakes trying to write the number. Alright, so I have just checked. Alright, so let me just say 0.125. Ooh, so look at that. I think it kinda makes sense. So it does make sense. As for me trying to make it make sense, okay, I'm coming. So we have 1/8. That's what we're going to use now. But I just want to show you with this, because for me, I saw 125. I know 5 to the power of 3. Come on, bro. I know 5 to the power of 3 is 125, and I know 10 to the power of 3 is 1000. Right? So I was like, 5 over 10 to the power of 3. Right? So yeah. But also, like, check this out. 1000 divided by 25. Right? So if I divide by 25, I'm gonna have I believe 5 over 40, and I divide by 5 both sides. In fact, I could have divided by 125. If I divide by 5, then this is gonna be 1 over 8. yeah yeah, almost thought the question was wrong, but yeah, the calculator came to my rescue here. So that means then in that case, I'm gonna write 1 over 8, and I know 1 over 8 is the same as 1 over 2 to the power of 3, which is the same as 2 to the power of negative 3, and therefore a equals to negative 3. All right. We have something beautiful here. Let's see. Okay, I have 2 to the power of 3x minus 1. I have 2 to the power of x minus 1 equals to, I have 2 to the power of 3. In fact, that'll be plus x. Then I have plus 9. Yeah. So now I'm urging everyone that we think about this one quite clearly. So we have a 9 there, right? And we have a couple of base 2s, right? Cool. So you know that the whole idea of this thing that we are doing is we're trying to make sure that our bases are going to be the same, and once our bases are the same, it becomes easier for what? It becomes easier for us to say, since the bases are the same, therefore the exponent has to be the same, and then wow, we are done, right? We're done. So we might need some space, so I'll do this. Yeah, and there's this thing also, like we there's this thing of, actually, you look at a problem and you just immediately go to it without further thinking about it. Right? It works most of the time. Because most of the problem you don't have to think about it. You see something, you remember something, you just put it there, and you're done. Everything is fine, right? So for this one, I'm seeing something very beautiful here, especially with the numerators. Because I changed the numerator now. Okay, you have a 1 there, right? You have a 1. Yeah, and this one, it can be, we can say maybe it is what? It's a square number, right? It's a square number, but yeah. So I was saying, look at number 1. What is number 1? Number 1 is a square number, because 1 squared is 1. At the same time, it's a cube number, right? And I would say to some extent this is a challenging question because it has something that we may not actually see, right? We may not actually remember when we were doing a difference of two cubes, né? This is exactly what's happening here. We have 2 to the power of 3x, right, minus 1 to the power of 3. Right, so when we factorize this gentleman over here, we're gonna have 2 to the power of x minus 1. We're gonna have this guy squared, which is gonna be 2 to the power of x. Then it's a negative here, therefore we'll have a plus here. Now I forgot 2x. And then we multiply these two together, you have 2x. And then you square this one, 1, right? This is this when we factorize it. 2 to the power of 3. What? Oh yes, oh yes, oh yes, oh yes, oh yes. Plus 3 plus x plus x plus 9. Then of course this lucky is in a different color, so this divides this. You have 1, you have 1, 2 to the power of 2x plus 2 to the power of x plus 1, 2 to the power of 3 plus x plus 9. And then look at this, I'm getting 8. 2 to the power of 2x plus 2x, 2 to the power of 3x, 3 plus x. Yeah. Alright, cool. And then plus 9 minus 1. That is 2 to the power of 3x, 3 plus x minus 8 plus 8 plus 8, right? 2 to the power of 2x plus 2 to the power of x. What do you know 8 to be? It's 2 to the power of 3, right? So now we have something really beautiful. Alright, cool. So still gonna need space. 2 over 3, it's a common factor, highest common factor. So you then have 2 to the power of 3, 2 to the power of 2 to the power of it's gonna be x plus 1. And then here 2 to the power of x, then I have 2 to the power of x plus 1. Right, then do realize, can I continue the side now please? Do realize these two, they will cancel each other out, they will divide each other out. So you're gonna end up with 2x equals to 2 to the power of 3, therefore x equals to 3. Right. So yeah, I will say so far this has been the most challenging example we have done when it comes to solving exponents. And what was challenging about it, it was this difference of two cubes that we had. It's not easy to see them, let's be fair, right? It's not easy to see them. If it was easier for you, I'm very happy, and hey, look, you're going very far in life. But yeah, it's not very easy to see, but with more practice of such examples, you get to be able to see, or you get to be exposed to such problems, and life becomes easy. So let me solve number 9. I'll solve it right here. Number 9 is a bit interesting, yeah, because here you have 2 to the power of x squared minus 2x minus 3 equals to 2 to the power of 0. Therefore x squared minus 2x minus 3 equals to 0. And then here it's just your two brackets, then x minus 3 x plus 2, x plus 1. Right, so yeah, 0. and therefore x equals to 3 or x equals to minus 1. Right, this one, yeah. So guys, remember if you cannot factorize this fast, I did show you the mechanism of factorizing this fast, which is you just open your two. If your coefficient here is 1, you open your two brackets, ask yourself a question: are there any two pair of numbers I can multiply to get minus 3? And that same pair I can add or subtract to get the middle term, which is minus 2. And if you find them, you put them there in the brackets with their respective signs. So it's not complicated at all. But should you forget, that other method, it always works. So you just go 1 times 3, and then you try to find the factors of 3, which gives you the last term when you multiply, and they also give you the middle term if you add or subtract them, right? Yeah, so that is that, my friend. Let's do the last one. Here. Okay, this one is also gonna be very interesting. You see, that's what I meant when I say the more you do this problem, the easier it becomes. Because look at me, I am seeing this number and I'm already thinking, difference of 2 cubes, right? Because here I have 3 to the power of 3 x minus 1, and then this is 9x, and I'm sure it's gonna be cancelled out, so I'm not gonna try to even factorize it. Let's say, all right, so this number here, it gives you 3x minus 1. It also gives you 2x plus 3 to the power of x plus 1, right? And this 3, okay, I'll do it later, but I want to do it now. This 3 to the power of 2x is the same as 9x, right? You still have your so this one I'll just see how it is going to help me later on. Cool. Then you have 9x plus 3x plus 1, and then of course this divides that. Of course, you are left with 3x plus 1, or 3x minus 1 being equals to minus 8 over 9. Then I have 3x, I have 1 minus 8 over 9, I have 9 over 9 minus 8 over 9, 1 over 9, 3x, that is the same as 3 to the power of minus 2, 3x, therefore x equals to 3, minus 2. Yeah, you see how easy this question was. But had we not done number 8, we would have, bro, like, it's so that's what I'm saying. With more examples, guys, you get exposed to tougher questions, and in the exam you're gonna chow this thing. I believe this is the last video for the chapter, so the next one will just exam questions, right? And yeah, I will see you there, guys. I'll see you there.